In this video, I am going to explain about greedy knapsack. So the greedy knapsack is nothing but the knapsack problem only. That knapsack problem we are going to solve by applying a technique called greedy technique, also called as greedy method. Hence, this is called as a greedy knapsack. So already I have explained what is knapsack problem. Okay, for the new viewers, I will explain once again what do you mean by knapsack problem. In the knapsack problem, there are n number of items given. Okay, number of items are given. Okay, and we know that every time, so each item means that every item is having some what weight. Okay, let us take, if I say marker is having some weight. And if I take the shirts, that it is having some weight, a board is having some weight. You take any item that is having weight. So our number of items it is having some weight. So that will represent as a W of, that means W of 1 to n. That means weight of items 1 to n items. Since we say one item that every item is having some profit. Okay, so everything. See, this board is having some value or price, or this marker is having some price, or clothes having some price. Every item is having some price. So that I will say profit of each item is 1. This is 1 to n. That means profit of 1 to n item. This is the profit. Okay. And then given what? One knapsack. Given one knapsack means just assume it is one what? Carry bag. So every carry bag is on some maximum capacity. Okay. Suppose if I say some hand cover, maximum it can have some 5 kg of items. For example, up to 3 kg of items like that. A knapsack means one carry bag, which has some maximum knapsack capacity. So that I will take it as M. It indicates knapsack capacity. Okay, now what we have to do? So given some number of items, out of this number of items, we need to select few items. Okay, out of many items, few items we need to select in such a way that we should get maximum profit. Condition is, whatever the maximum knapsack capacity is there, we should not exceed that capacity of that knapsack. That means, for example, assume that knapsack capacity is, for example, say 10 kg. Now, out of n number of items, we need to select few items such a way that the total weight of the selected item should be less than or equal to 10 kg. Should not exceed 10 kg. Suppose this is not 10 kg. So like that we need to select. Okay, suppose 10 kg capacity this carry bag is having, we cannot take more than 10 kg. So that means total weight of the selected objects should be less than or equal to 10 kg. That is the first condition. And we need to select the items in such a way that we should get the maximum profit. These are the two conditions. Okay. Now, in order to solve this problem, knapsack problem, since we are applying greedy technique, this knapsack problem is called as greedy knapsack we are calling. And so in part 30, I have explained already dynamic knapsack. The dynamic knapsack is also called as 0-1 knapsack. So there, in that problem, we have to select the complete item or we should not select only. It is not possible to take half of the object, half of the item, or 30% of the object, or 75% of the object. We can take part of the object. Suppose if I want to take a marker, I will take complete this one. I cannot take only 30%. No, it is not possible in the case of dynamic programming. So that is the condition there. Okay. But what is the disadvantage of the dynamic knapsack? There, assume, I already selected few items in the knapsack. Assume only some portion is free. Okay. Assume half kg is free. We cannot take half kg of the remaining items. So there the dynamic, it is not possible to take some part of the object, like some part of the marker or some part of the board will take. No, it is not possible. Either you have to take the complete object, complete item, or you should not take. You should not take part. That means either complete means what? 100%. 100% means what? 1. Okay, or 0. 0 means what? 0. 0% means 0. This is one dynamic knapsack. But in between greater than 0 and lesser than 1, whatever you got from 0.1 to 0.1 to 0.99, all the called fractions. But that means, for example, if I say 0.70% of the object means 0.7 of the object. Okay, similarly, say 25% means quarter part. Okay, suppose similarly this is 0.25. Similarly, if I say 50% of the object is half of the object. So that is not allowed in the case of what dynamic. But here in this greedy knapsack, it is possible or it allows to take even the fractions. That means even though suppose sometimes what happens is not possible to complete, I can take part of this. That is fraction of the object also I may take. Hence this is also called as fractional knapsack. Okay, since in this greedy knapsack it is allowed to take some part or fraction of the object, this greedy knapsack is also called as fractional knapsack. So hope up to here you people understood. Okay, so now the question is how to select the items by applying greedy technique. Okay, so again greedy technique we are using in order to get the optimal solution. Okay, in order to, again, this greedy technique, greedy method is applied to the problems in which we are having so many objects or so many items we are having. Out of so many items, we are selecting few things. Okay, now the question is, on what basis we need to select? In order to select the items out of many items, so greedy technique offers three policies. Okay, so the one is the first one, policy 1. Policy 1 says select the lightest element. Okay, select the lightest element as much as you can fit into the knapsack. How much possible you can take, but lightest first preference is light, because when we hang the knapsack, instead of filling more weighted elements, if you take lesser weight elements, we can take more elements. When you take more objects, obviously you get more profit. That is the intention of this one. Okay. Second policy says, now policy 2 says, instead of taking lightest element, take the element which is having the maximum profit. Whichever the element is having maximum value or maximum profit, you take that element as much as you can fit into the knapsack. Okay, because since we need to get the maximum profit, you select the item which is having the maximum value. That is the policy 2 says. Okay, but policy 3 says you select the item which is having maximum value per item, profit per unit weight of the object. That means you calculate, for example, for 10 kg, 120. So for 1 kg, how much? So like that, you calculate how much value or profit you'll get per unit weight. So whichever is having maximum profit per unit weight, that you said. That was the policy 3 says. Out of these three policies, these two policies, okay, first two policies will give our optimal solutions very rarely. That means 10 out of 10 times we are not getting optimal solution if you are selecting policy 1 or policy 2. It will give optimal solution, but not always. Okay, it will never guarantee that always I will give you the optimal solution. That guarantee we won't get. We may get, we may not get. Okay, that is the power. But policy 3, 10 out of 10 times you will get optimal solutions. So it will guarantee that if you apply these techniques, you will get what? Optimal solution. So in order to select the few items out of n number of items in this knapsack problem using greedy technique, we are applying policy 3. Okay. Now to indicate these three, the difference between these three, I will take one small example. Now let us consider there are three items, number of n. Number of items, there are three items are there. There is item number 1, item number 2, item number 3. And item number 1 is, we are having total 18 kg. For 18 kg, if I take complete 18 kg, you get a profit of 30 rupees. Okay, for example. So second item is on 15 kg. For 15 kg item, this is 21 rupees. Similarly, item 3, so it is having 10 kg, and for 10 kg is 18 rupees. Okay, 18 rupees. And we are having the maximum knapsack capacity. That means our carry bag contains maximum 20 kg it can take. Okay, so this is what the problem given. Now let us apply what? First policy. First policy says what? Lightest element. Okay. Now if I take, assume this is my what? knapsack capacity. This is what? Initially it is what? 20 kg. 20 kg. Now initially it is completely empty. Okay. Now out of 20 kg, now which is the latest element? Which is the latest element which is having less weight? So this is a less weight, 10 kg. Now take 10 kg. Now if I take item 3, so 10 kg, out of 20 kg, 50% space is consumed. Now this out of this, now item 3 has taken. Since item 3 is 10 kg, now remaining capacity is now only 10 kg. 10 kg is occupied, remaining 10 kg is remaining. So if since 10 kg I taken, profit what I got? Profit 18 kg I got. Profit is what? 18. Now remaining 10 kg I am having. But next 10, so next among these two, what? Which is the latest element? Latest means 15. But I cannot take complete 15 because remaining is only 10 kg. So I will taking 10 kg out of 15 kg. That means 5 to 2 by 3. 2 by 3. 2 by 3 of, that means for 15. 10 out of 15. Okay, that I am taking. Okay. Since I am taking 10 kg out of 15 kg means 5 to the 10, 5 3 is 15, 2 by 3, means 2 by 3, 2 by third of how much? 15 kg. It means again you take 3 5s are 5 to 2, 10 kg I am taking. Now if I take here completely this one, item what? Item 2. Item 2, now it is completely filled, now 0 capacities. Now completely 20 kg is occupied. Now, how much? Since I take 2 by third of the second item, item number 2. So how much profit? Total 21. So 21. So 2 by third of 21 again. So 3, 7. Okay. 3 7s are 21. 2 7s are 14. That means 14 rupees plus 14 is equal to 32 rupees I got profit if I follow what? Policy 1. Now let us apply policy 2. So policy 2 says what? Policy 2 says what? Again, let us take maximum knapsack capacity is 20 kg. Okay, 20 kg is completely is remaining. Now policy 2 says what? Take the maximum profit item. Here out of these 3 items, which is a maximum profit 30 is the maximum profit. Okay, so that is item number 1. Item number is how much kg? 18 kg. Now if I fill this one, almost it is 18 kg is filled. So that is item number 1. So now out of 20 kg, it consists 18 kg. So now remaining is only 2 kg is remaining. Since profit how much is got? Complete 30 I got here with only one item. Okay, so now remaining how much? 2 kg. Next maximum profit is what? 20. So now I am taking how much? 2 kg out of 15. 2 kg out of 15. That means 2 kg out of 15 kg I am taking. Okay, so that is 2 by 15 and its profit is how much? 22. Suppose if I take 2 kg of this what? Item number 2. Okay, item number 2. So then remaining is 0. Complete is filled. Now 2 by 15 to 21. Okay, so this is equal to, so 2 by 15, 3 5s are, okay, 3 7s are, okay, 14 divided by 5. 14 divided by 5, how much I will get? I think 2.8. Okay, 2.8. So 30 plus 2.8, 32.8 rupees. This is much greater than 32. See, if you apply policy 1, you will get profit 32. If you apply policy 2, you get 32.8. Now let us apply policy 3 for this one. Okay, policy 3 says what? You don't take all these two, so you check or you find out for 1 kg how much. So if it is 18 kg for 30 rupees, for 30 kg, sorry, for 18 kg 13, for 1 kg how much? So if I make 30 divided by 18, so I get 1.67. That means for 1 kg it is 1.67. Similarly, suppose if 15 kg 21 means for 21 kg, so how much? For 51 kg 1.40. For 15 kg 21, for 1 kg 1.40. Similarly, for 10 kg 18 rupees means 1 kg it is simple 1.80. So this is what the price or profit per unit weight. Now I need to check this one. Okay. So now I will apply what? Policy 3. So now policy 3 says what? Again, assume this is my maximum knapsack capacity 20 kg. Now here which is maximum profit? 1.67. 1.40, 1.80 is the maximum profit. Now you take this complete item. This item is having a 10 kg. So that is item number 3 I am taking. So this is occupied 50%. So now this is our 10 kg. 10 kg is occupied is remaining how much? 10 kg. So 10 kg is remaining. So now since I taken this one, I got profit of 18 rupees plus. Okay, 18 rupees I got. Next, remaining 10. Now this one is gone. Now this one completely taken for. Now remaining 2. Among this remaining 2, this is having the maximum profit per unit weight. Now for this one, how much is there? 18 kg is there. But I left with only 10 kg. So I cannot take complete 18 kg. Now take 10 kg out of 18. Okay. So that is 10 out of 18 I can taking. So for that profit is what? 30. Okay. For 1 kg or 1.6 means for 10 kg I am taking, that is 16.7. 16.7 means so this is 34.7 again. See, if you apply policy 1, you are getting profit of 32. If you are applying policy 2, 32.8. So if you are applying policy 3, same problem, I am getting 34.7. So this is the maximum. So that's why I told among these 3 policies, policy 3 always gives us the optimal solution. But these 2 also will give, but guarantee, we don't know when it will give. Okay, it may give or it may not give, but it is not assured or always it will give what? Optimal solution. But policy 3, 100 out of 100 times it will give optimal solution. So whenever we are applying greedy technique, whenever we want to select some items based on the greedy policies, we are referring what? Policy 3 only. Okay, so just I took one example just to show you what and all the policies are there in order to select the items by using greedy technique. And these are the 3 policies, and with this we came to know that always policy 3 will give us a maximum profit. Hope you understand up to here. Now we will write the algorithm for this knapsack problem by applying greedy technique. So now we'll write the algorithm for greedy knapsack. So as usual, I'll give some name called greedy underscore knapsack. Okay. So parameter to be passed are number of elements n, maximum knapsack capacity m, and then weight of the objects. So that is array 1 to n. So then profit of n items 1 to n, and then that's it. Number of items, weight, profit, maximum knapsack capacity. That's it. The parameter to be passed. Now, so what is the input? These are the inputs. What is the output? So for this type, for this problem, I am going to take one more array called a solution array called x. Okay. Now this is the array. It tells which are the items we selected in our knapsack in order to get the maximum profit. Okay. So for example, let us take now. Now we are having only 3 items. Item number 1, item number 2, item number 3. Item number 1, item number 2, item number 3. Now if I say, for example, in the previous example what we discussed, in that we have taken complete 10 kg. Complete 10 kg of item number 3. So write 10, 1.0, that is complete 100%. Okay. So now then we take 10 kg out of 18 kg. 10 kg we took out of 18 kg. So that means how much we take? 10 out of 18 kg means 10 divided by 18 is equal to 0.56. That means item number 1 we took 0.56 kg, 0.56%. And we have not taken 2, so this 0. So that means it indicates if you take 56% of the item 1 and 0% of item 2 and complete item 3 if you take, we will get the maximum profit. So this is the array gives us the information about which and all the items you have selected and how much you selected the each items. Okay, if you select these items this much, you will get the maximum profit. Okay, this is the information. This is the output array what we are using in this algorithm. So it's called solution vector also. It's called output array, solution vector, whatever you can call. Okay, hope you people understood. Now I'm coming for that. Initially what I will do, initially I will make all are what? All are 0. Okay, 0.0, 0.0, 0.0. Initially make all of 0, 0. To make this output vector x 0, 0, I am using one for loop. Okay. For I is equal to from 1 to n, 1 to n number, 1 to n, you do what? X of I am storing 0.0. That's it. This for loop is just to initialize the output vector or solution vector. Now, since see we human beings, we are having eyes, we can see into the table and we can see which is maximum, but a processor cannot see. So what we will do, we will sort these items in such a way that profit per unit weight should be greater. In the descending order, these values I will sort in the descending order. If I sort in the descending order, what I will get? See, this is the item number, and I will get what? Weight, profit, and profit per unit weight. Okay, so 1, 2, 3. Now, which is the maximum profit? 1.80. So 1.80, and whose weight, whose profit is 18, and whose weight is 10, and that item number is 3. Item number is 3. Okay, next maximum is 1.67. 1.67, and whose weight is what? Whose profit is 30, whose weight is 18, and this is item number 1. And this item number 2. Item number 2 is 15 kg, 21 rupees profit, and it's 1.40. This is after sorting. Okay, here we sorted these items in such a way that profit of first, this one, okay, profit of one item divided by one item should be greater. So this is greater than profit of second. Okay, profit of 2 divided by 2. Okay, similarly this profit is greater than this one. So greater than or equal to profit of third. So like that we need to sort. Okay, that is the first step we have to do. Okay, for that what we do, we'll write here. Sort the items in the order. In general, right? P of I divided by W of I should be greater than or equal to P of I plus 1. Okay, wait. Just I redraw this. That's it. So first you sort these items, sort the n number of items in the order P of I per Wi greater than the next item. Okay, so this item should be greater than this item, and this should be greater than this one. That's what I've done in general. After that, I made this solution vector or this array vector, output array 0, 0 initialized. Now what? Initially, when I get this knapsack, initially it is empty. So its maximum knapsack capacity, how much? For example, something. So initially this empty. So how much is remaining? Complete is remaining. Okay. So that was like U. Okay. Now U indicates remaining capacity of the knapsack. Remaining capacity of knapsack. That means now right now how much capacity is suppose for example say it is 15 kg. How much kg I can still fill? Complete 15 kg. That means that was remaining. Right now, remaining capacity is 15 kg. So that's what the U. So initially, that U is how much? How much is the maximum knapsack capacity? That much is initially available. Okay. So that's what. Okay. Now what I have to do? Now I need to check one by one in this order. This is the first one I am checking. Second one I am checking. Third one I am checking. This is the item number. So original item number. Okay. So now for that, for I is equal to 1 to n, do what? Now I need to check if weight of the ith item, that is weight of the first item weight is what? 18 kg. If this is greater than, if it is greater than what? If it is greater than the remaining capacity, then what you have to do? Then you have to break. You come out of the for loop. Come out of the for loop. That's it. End if. Suppose the item is not greater. See, weight of the object. See, here I did one mistake. So here I need to change. Okay. This 18, 15, 10. 18, 15, 10 is the weight actually. So this is should be weight. And this is profit. While rewriting, just I interchange. So everything is fine. Same concept. Okay. Now, if the weight of the object, weight of the 10 kg, 10 kg is remaining greater than u, if it is greater means, so weight of the object is more, that much capacity we don't have. So we come out. Suppose if it is not greater, that means weight of the object is less. If it is not greater means what? It is lesser or equal means I can take. Okay. Assume the first object is 10 kg. Assume it is having what? For example, say okay, let us say 15 kg. Now weight of the first object is what? 10 kg. 10 kg greater than 15? False. So now what I will do? Now I can take this object. I can fill this object. If I fill this object, how much I can? Since weight is 10 kg, remaining is 15 kg, I can take complete this item. Complete this item means now I have to make this item number 3 as 1. Complete item I have to take. So for that I will do what I will do. So x of I should be equal to 1. Complete item I am taking. Okay, this is when weight of the object is greater than object, you come inside. If it is false, it is not entering, it comes out. If it is condition is false, coming out of the if block. Okay, so now it is making fill. Okay, so okay, when it is false, it is not greater. Not greater means either less than or equal to. Suppose assume remaining, okay, total capacity is 8 kg. Knapsack weight, this particular item is 10 kg. 10 is greater than 8, true. Not possible to take because I am having only 8 kg capacity. This is 10 kg. 10 kg I cannot fit in 8 kg. So you come, so condition is true, comes inside, it breaks. That means comes out of the for loop. But in this case, in this example, it is not true. So suppose I am taking, since I am entering this, since I am taking this 10 kg item, suppose it is 20 kg. So now it is what? So this is completely filled, this much is remaining. If I take this, remaining capacity remains same? No. It has to get reduced. How much it reduced? How much item you are selecting, that much it is reducing. Suppose that item is 10 kg, divided by 10 kg. Suppose this item is 15 kg, 20 minus 15. Suppose this item is 12 kg, 20 minus 12. Now in this case, this is 10 kg, this is 20 kg, 20 minus 10. So that means I have to reduce the remaining capacity. Now remaining capacity is reduced by how much? Weight of that particular object. Okay, so that's it. This is end for. So now once I coming out, for example, say suppose weight of the object is more, remaining capacity is less. That I cannot take complete item, but I can take how much remaining I can take, right? So now I'll come out, and still if we are having weight of, okay, still if the number of items are there, still some items are there, that is I is less than or equal to n, then simply take x of I is equal to how much weight is there, that one. So that one you take out of the remaining capacity. Okay, how much, no, it should be reverse. Okay, how much remaining capacity is there out of that weight of that object. Suppose our remaining capacity 8 kg. Okay, remaining capacity is 8 kg. But total weight is 10 kg means we take 8 kg out of 10 kg. That's the meaning. Okay, so that's it. End if, and finally return what? Our output array, X array you have to return. Okay, now let us stress. Okay, hope you people understand. Now if you are not understood, still clear, now we'll trace this algorithm, you will understand completely. Okay, so now let us take the same example, this example only. Initially, see, I sorted this first step, sort the items in the order, in the decreasing order, that I did. Next, I filled the XR into 0, 0. So I filled this 0, 0. Okay, so now you initially, so this is what the problem is solved, right? So this is 20 kg. Now my remaining capacity is what? Okay, U is equal to maximum capacity 20 kg. That means remaining capacity 20 kg. Now I is equal to 1. Okay, this item I am checking. This one is item 3 I am checking. Now weight of that item, this item is what? 10. 10 greater than 20. 10, this is what? U is 20. 10 greater than 20. False. 10 is not greater than. Comes out of the if block. Now I am storing 1 into x of I. That means I is the item number 3. So that means I am storing the complete item 1. That means third item. That means I taken the third item means, so okay, item number 3 I filled means this is occupied. This is occupied now. Okay, how much is occupied? 10 kg is occupied. So remaining capacity is what? Now remaining capacity is 20. Initial 20 minus weight of the 10. 20 minus 10, 10. Now remaining capacity is become 10. Now next it goes to the next iteration. I becomes 2. Now this item is done. Now I'm checking this side. Now I'm taking this item. Now this item weight is what? 18 kg. Now remaining capacity is 10 kg. Out of 20 kg, 10 kg occupied, 10 kg is remaining, 10 kg is remaining. Now weight of the next is 18 kg. 18 kg greater than 10. 18 is greater than 10. Yes, 18 is greater than 10. So comes inside brakes. That means we use brake statement to come out of the loop. Okay, in between. So since 18 is greater than 10, so it comes out of the for loop. It comes out of the for loop. It checks. I value is what? 2. 2 less, n value is what? 3. 3 number of items. 2 less than or equal to 3. True comes inside. So u, how much? 10. That means 10 out of weight of that object is what? 18. That means 10 out of 18 kg. You stored 10 out of 18. So again, 10 divided by 18. 0.56. That means you store 0.56 into what? X of I. So this is 0.56 because this item number 1 I stored. So next, that's it, I come out. Okay. So now it will so say it's what? Item number 1. So item number 1 is what? Okay, now completely filled. Now, so it will be 0. So now item number 1 0.56 and this is completely. So complete means item 3 is what? Item 3 is 18 profit. Profit is 18 plus this is 0.56. 0.56 of what? 30. 0.56 of 30. So 0.56 into 30 how much? Is what? 16.67. So 18 plus 16.67 is equal to 34.67. That is what we got earlier. Okay. So we got, now finally I am returning this X. So this is my output array. So that means if I take 56% of the item 1 and complete item number 3 and 0% of item 2, I will get the maximum profit. This is how greedy knapsack works. Hope this greedy knapsack algorithm you people understood. Okay. If you have any questions, please write it in the comments. Thank you.